Hey, welcome everybody. Welcome to deep dive number 3, Introduction to Smartweave for the Open Web Foundry. So today, Jakub, the founder of Redstone, is going to be telling us a little bit more about Smartweave contracts that they've developed for the Arweave ecosystem and also how you can leverage those for your project. Also, Asha from Redstone will also be telling us about Redstone Academy and putting some code up there so that you guys can actually have like a little bit more of a technical walkthrough. So make sure to also tune into the deep dive tomorrow with Cedric, who's going to tell us a little bit more about our local, the Arweave testnet, and then also ArcB. But without further delay, Jakub, you can come up here and tell us a little bit more about Smartweave.
Hi guys, thanks for having me today. I'd love to tell you a bit more about what we are working on, which are the Smartweave contracts made by Redstone. And recently, we are going through rebranding, so we decided to call all of the tools, services, and SDK, and keep them under common brand name called Warp, which is, in our view, a more catchy name than Redstone Smartweave SDK, which was kind of an awkward term, especially to use within the code. And also Warp is cool because it's got an AR inside, and it's an analogy to the increased speed of evaluation that we got through the cooperation with Bundler and the ability to pack the transactions and get almost instant finality with the guarantee of the transaction to be properly seeded by the bundler network. So let me start by showing you, or maybe let me start with our story, how we started working on Smartweave, what was the origin, and why we work on Smartweave. So roughly a year ago, we needed a solution for our Oracle system to keep a registry of data providers with the definition of sources. Maybe I will show you the screen. So we deliver data to different protocols, mostly focusing on DeFi. And we gather tons of assets that we monitor, and also we got multiple data providers. So if you look at the list of the providers, there are currently around 30 nodes, and every node has got a manifest, which is a definition of which assets are monitored, what's the interval, etc., and what are the sources. So it's quite a lot of data, and we wanted to keep everything fully transparent and visible to end users. So therefore, we wanted to leverage smart contract infrastructure. And as we persist all of the information on Arweave, we decided also to build our smart contract layer for the registry on Arweave. So that's how we persist the transaction. Also, the registry is there. So we started with Smartweave initial contracts, which was an amazing idea introduced by Sam. But we struggle a bit with the speed of smart contract evaluation, because Smartweave is based on the assumption that the code and the inputs to transactions are stored permanently on Arweave, and whenever you need to access the current state, you can evaluate it on demand, which is a great vision. But when you are trying to implement that in practice, the evaluation from the initial state sometimes may be really long and expensive in terms of resources. So if your contract's got a few hundred or few thousand of interactions, which happens for some PST tokens, then the end users will forced to wait something like 30 minutes up to 30 seconds up to 3 minutes for the state to be computed before they can interact with the contract. Therefore, we implemented a lot of enhancements to speed up the execution with caching, with optimizing access to Smartweave transactions. And once we started working on that, we also see other options how to improve the whole ecosystem. So let me show you the current version of our product, which is Warp. And the vision is for the smart contracts to be processed fast. So instead of waiting a few minutes for the state evaluation, and end users should be able to access the final state of a contract under a second. Let me show you. So that's a small widget on our website that actually performs a Smartweave transaction. So the contract, which is connected to this widget, is a simple PST contract, which is a standard for tokens within an Arweave ecosystem. And probably if you are thinking about monetizing your solution, of raising some extra funds to speed up the development of your product, PST tokens are like an amazing vehicle for bootstrapping the product development and engaging both your community and investors. So PST token is kind of a token that the owners can have a share in your further profits. So if you, let's say, get an investor that truly believes that your service will generate revenue, then the investor can buy some tokens, and you can implement a logic for sharing the revenue with token holders. So that's very popular pattern among Arweave projects. So we implemented a test PST contract. As you can see, I just executed a transaction a moment before. And here I can see the contract using our tool, which is called Sonar. So apart from seeing the list of transactions, you can also see the code of a contract, and you can get the state fully evaluated with a list of all of the balances, etc. So that's a very useful tool to monitor what's happening within your contract, to access the code. If some of you guys are coming from the blockchain space and are familiar with tools like Etherscan for Ethereum, then you may see Sonar as an equivalent built on top of Arweave and acting as a smart contract explorer. And so the Sonar is a kind of a development tool, but also could be quite useful for end users to validate the state of a transaction, but also improving the speed of Redstone smart contracts, Warp. We needed to develop a few important pieces of infrastructure. So the first one, as I mentioned before, we utilize Bundler, which is a service that allows you to pack together your individual transactions, keep them in a waiting queue, and provide you a guarantee that finally the transactions will be seeded on the Arweave chain. And from the point of view of developers, it's an amazing tool because you receive a guarantee that the transactions are seeded immediately after submitting a transaction. And Bundler is responsible for handling the process of seeding data and also for handling all of the scenarios connected to network reorganizations, to forks, etc. So it's like really useful to have a strong commitment of eventual presence of your data on chain. So we utilize Bundler, but we needed an extra gadget on top of that, which we call Sequencer, that actually orders the transaction whenever you submit them. So we get a deterministic way of evaluating the final state. So if all of the transactions are ordered, then anyone can execute them within a given order. So sequencer is a really important piece of the infrastructure. And when we properly record the transaction, then there is an other side of the execution, which is actually evaluating the state. So Arweave is great for the storage, but getting the data may be tricky, especially if you need to query a few hundred or even a few thousand of transactions linked to smart contracts. Therefore, we built our own indexer, which we called Gateway, and it's responsible for monitoring the network, picking up all of the transactions that are linked to smart contracts, and indexing them for the fast retrieval. So let me maybe show you the gateway repository. If you are interested in learning more, like how the gateway work, what are the internal subcomponents, and what's the process of picking up transactions and indexing that, I invite you to the repository. The code is fully open source, and you can read a lot about interesting facts like how the Arweave transactions are being processed, how to handle like the forks in the network, the orphan transactions, etc. So it was a lot of work done by my friend, but fortunately we get a really stable and robust tool for getting the data connected to smart contracts in a convenient and fast way for the evaluation. So another important piece of the path is the code that actually executes a smart contract and process all of the transaction. And we call it DAN as a distributed execution network. And the core of the DAN is our virtual machine that can accept basically the pure JavaScript code, which is great for prototyping and starting your journey into the smart contract world. But if you'd like to build something more mature, secure, and performant, we highly recommend using a WASM environment, because first, your code is fully sandboxed. Second, WASM is much faster as optimized to run the code. And also, we believe that the quality of a code written in Rust, which is like a fully compiled language, could be much more maintainable for, let's say, more complex projects. When you get a lot of contracts and you want to have a better developer experience. So as I mentioned, we got Sonar as a tool to browse the contract. And also, we created dedicated test network for running and deploying your smart contracts before you are ready for the mainnet and before you can pay for the actual transactions. So the testnet is based on RLocal, a tool from Texture. We just added a few improvements just to have a persisted state and a few optimizations to index all of the transactions in the test network, which is quite convenient. And if you are using Sonar, there's a simple switch to the test network, and you can see all of the interactions with your contract in the real time. So we, as I mentioned, we took the basic Smartweave code. We also produce a description of the original protocol that you might find in our work repository, but we wanted to add a few extra features to make your life much easier. So one of the problems that we struggle with were the interactions between contracts. So let's imagine you get one contract with tokens and maybe another one that's responsible for voting or some additional logic for token staking. So your users can provide a collateral, or they can simply stake tokens to get some reward, etc. So there are like tons of patterns that are very popular in other blockchain environment. And we believe that inter-contract communication is a really key concept to be implemented to allow Smartweave to handle like more complex use cases. So with our extension, it's really easy to call another contract from S1 contract using simple instruction write foreign contract when you provide an ID of an external contract, and you simply call a function. So there is no need for some extra tools, some intermediary contracts, anything that could be hard to grasp. You simply can invoke another contract from your own contract. As I also mentioned, the integration with Bundler was a big improvement for the speed of processing, but you can not only bundle interactions, so the transaction like sending tokens or minting them, you can also bundle the contract deployment, so there is no need to wait for a few blocks, like 5 or minutes or half an hour to see your smart contracts being live on the network. You can bundle the contract deployment and the contract is visible almost immediately. And that's super useful if you get a scenario when you are deploying multiple contracts for different users. So if you are developing something like a dedicated wallet to hold your NFTs or some dedicated vaults for your users, that's an extremely useful tool. Also, we've seen a lot of requests for the randomness to be accessed within a smart contract environment. So one of the most common use cases was the generation of NFTs. So if you are creating a collection, then a very common pattern is to allow your users to get a random item from that collection. And obviously a very naive approach will be to base the randomness on the block hash or any kind of a pseudo-random entropy within the network, but that obviously could be exploited by the miners. So we studied the problem and we implemented a solution that is kind of the most popular approach in the major ecosystems like Ethereum, which are the verifiable random functions. So whenever you receive from our sequencer a random number, then you can perform your own verification that the given value was properly derived from the public key of the sequencer. So therefore, you know that a service that is providing you this randomness cannot corrupt it, cannot exploit it for their own purpose. You can always verify the randomness before actually using it. And as I mentioned, there's what's happening with the transaction, but actually it will be much easier to follow if you take a look at this chart when it shows you as a life cycle of a smart contract transaction. So it all starts with a sequencer. So whenever a sequencer receives a transaction, it gives it an order. So we know which transaction came first, which came later, and they get a deterministic ordering for execution. Then we send it to the bundler, which is responsible for persisting it on the Arweave network. And bundler network gives us the commitment, a strong guarantee that eventually the data will be on Arweave. And as soon as we get that guarantee, we can index all of the information in our gateway. So for the faster retrieval, we add some metadata and we keep an index of the transaction. And also what's important, we have two inputs. So if you like the bundle approach for the speed, which is recommended, that's fine. But if you're somehow reluctant to that solution, you can also directly use the Arweave network, see the transaction yourself, and our gateway will be also able to pick it up and properly index that. So when the indexed transactions are actually input for the evaluator, which is our SDK, that can compute the final state. But also we created something that we call DEN, Delegated Evaluation Network, which is a set of nodes that can help you to facilitate the process. So the code could be either evaluated and executed by your own service, it could be evaluated by an end user in a browser, but delegating that process to the decentralized network of node can actually gives you an immediate final state of a contract, because the nodes are listening to all of the interactions and can evaluate the state of a contract as a new interaction arrives. So it's much faster, and also it's more secure because it's a set of specialized nodes. So your users do not need to directly interact with the contracts, as it's been handled by that network. Okay, so this is the architecture of our SDK, if you're interested. So we wanted to decouple different levels of transaction processing, so anyone is able to provide their own input. So if you need something, let's say a more advanced solution for your code, you can try to bring in some custom logic, and we wanted to separate everything in modules, so it's possible for developers to enhance the execution environment. We got some resources. Asia will show you probably the most popular one, which is Redstone Academy. And there are a few projects that actively use the framework, really big brands in the community. One of them is Bundler, that is using that to manage their staking. Another one is Pianity, that uses that to manage their NFTs representing music tracks. Also, we work quite closely with Acard, which is a tool for managing data vaults, so kind of a decentralized Dropbox with a strong pressure on user privacy, as they use quite sophisticated encryption mechanism along the way. And we also work closely with Finance, which is trying to bring DeFi solutions to the Arweave ecosystem. So that's an overview of Warp. Obviously, it will be great if you can keep it interactive. So if you get any question, if you are wondering how your project can utilize Warp, we will stay after the presentation, and you can directly ask for advice, and I'll be happy to help you. So let me now invite Asia to tell you a few words about the Redstone Academy, how it's structured, how it works, and how it could be useful for you.
Perfect. Thank you, Jakub. Yep, Asia, if you could just come to in front of one of the mic stands there. Perfect. You're now being, yeah, you got it. You're now being spotlighted. And then if you could just share your screen.
Okay, I hope it works, right?
Yep. Perfect.
Okay, so yeah, I'm Asia, and I'm a software dev working currently on Warp contracts. So I will just present you one of our tools, which Kuba already mentioned, and it's Redstone Academy. And it's a tool we built it for community, just so everyone can start easily writing some Smartweave contracts on Arweave. So yeah, you can use it for like basic usage, but we are also thinking about some more advanced examples. So currently it looks like this, and we have 2 tutorials in here. But we are still thinking about expanding it. We have a lot of ideas for some other tutorials, and also our community gives us some ideas. So whenever you feel like something is missing, or there is something you would want to learn, I think you can reach to us on Discord, and yeah, just talk to us. So yeah, as I mentioned, there are 2 tutorials. I will present this PST one today. I will try to do some really fast live coding. We will see how it will work. I'm a bit stressed out, but I hope it will work well. But there's also the other one, which is called Loot. And it's a really simple contract and an application which lets you generate assets, like magical assets, and also transfer them. So this is how the application looks like, the final one. Here are the assets, and yeah, you can see the addresses which own the assets, and then you can transfer them to some other addresses. So if you are interested in it, yeah, feel invited to go through this Loot tutorial, but we will focus on PST. I wanted to give you like a quick intro to PSTs, but Kuba already did it. So yeah, just to sum up, this is how you monetize apps and yeah, websites on Arweave. So the idea is very simple. So if you're a PST holder and there's a revenue coming from the app, you will get, based on your share, you will get some part of this revenue in ours. So we're gonna write a really simple PST contract. And yeah, you have a couple of sections in the academy. So first of all, this is the main part, which will guide you through writing the contract, the initial state, the contract source as well. So you will see how to write interactions and the contract itself. Then there's a crucial part. I consider it crucial because for me, writing tests is essential. So you will write some tests using rlocal, which is dedicated, let's say, for tests, local test environment. So you will write tests for each interaction on different ways, in different ways. So I really advise you to write as many tests as possible so your contract will be safe. Then we have this deployment section where you have the ability to deploy your contract either to our public testnet. Again, Kuba gave you a quick insight of how it works. Or you can deploy it to the mainnet. Today, I will try to deploy it to testnet. I think it's really cool to start with testnet, as you can test your contract in, let's say, real environment, which resembles the mainnet. But yeah, you can test it before deploying to mainnet, so I think it's quite safe. And then you have this front-end part, and in here, you have the front end already set up, so everything is written for you, so you don't need to write any front end. You will just need to do some basic stuff like initializing Arweave and Smartweave, and then writing some interactions. The application itself, in the end, will look like, just give me a second here, will look like this. So basically, you have these two main interactions, so you can mint some tokens or you can transfer them between addresses. So I will show you how it works in a second, but maybe let's start with cloning the repo. I really advise you to go through this whole tutorial. We will not do it right now because we don't have time, but yeah, it's quite a long tutorial, but there are some really cool insights of how it works, how you should structure your repo, your contract. So yeah, if you're interested, there are also some useful links. So yeah, I think it's a very good tutorial for starters, as it's quite simple. Well, yeah, let's clone the repo. Let's head to the folder. And as you can see, sorry, you have two tutorials in here. You have two repositories. One is for Loot, the other one is for PSC, and you have two folders inside. So you have the challenge one and the final one. The challenge means that you will need to write all the code, maybe not all the code, but some part of the code from scratch. So you will need to write the interactions by yourself of course, according to what's written in the academy. You will need to write the contract, the initial state, also all the tests. You will use our tools to deploy it later. But as I mentioned, we don't have time for this right now. So always you have this final version, and you can head to it if you are stuck or if you have any problems. So this is the ready to go version. I will just show you the contract part. This is the main function of the contract, the handle function. And based on what users writes in the input of the interaction, we will call proper function, proper interaction. So in this case, we have 3 of them, and we have 2 read functions, no, sorry, 1 read function and 2 write functions, so the interactions. So I will just show you one. This is how you mint tokens. So basically, you will get the quantity of tokens in the input. So then based on it, you will just add it to color's balance. Color meaning the person who's calling the interaction. Like always, you need some error handling. I really advise to write many error handlings because it's important to make your contract safe. And yeah, everything is written in TypeScript because I believe, I think it's better to structure your code this way. But in general, you don't need like a very advanced knowledge of TypeScript because it's only for, let's say, writing types. So I think it's fairly simple. But yeah, maybe as for the beginning, let's try to compile the contract. Because I mentioned it's in TypeScript, it's written in TypeScript. So the only thing you need to do with this contract is compile it to pure JavaScript because it's obligatory for it to be in pure JavaScript. So we will use as-built, and the script is here. I will not guide you through this script. It's quite simple. It's just going to compile the contract. So everything like from this part and put it in a dedicated folder. We have the scripts here, so we will just execute it. Okay, maybe let's install the dependencies as well. So I will just show you 3 main dependencies. First of all, our SDK. Right now it's called Redstone Smartweave, but it's going to be renamed to Warp very soon, Warp contracts to be more precise. Then you have Arweave. This is Arweave SDK, so a tool which is useful for interacting with Arweave itself. And then our local, which is useful for writing the tests. So yeah, the front-end part is written in Vue, but it's not really important right now. I will just wait for it to be installed. Just a bit. But maybe while it's installing, I will tell you. Oh, okay, so we're gonna run this little script, which will first of all clean the dist directory, which is not present because it's a fresh project. Then we will run this the script I showed you earlier, and then we will just copy the initial state file, so it's going to be in the same directory as the contract. So let's try to build it. No. Okay, very fast. So now we have all this part in here. So we have this contract in JavaScript, and we also have the initial state. So if we have it compiled, then we can deploy it, and we have already some tools in here. to deploy it to the test net, as I mentioned. Also, it's very simple. You just initialize Arweave with our testnet indicated as a host. Then you initialize Smartweave. Of course, we have this factory, the node factory, because we are in node environment. Then we just need to generate the wallet. This is for testing purposes. Usually, you will need your real wallet when on mainnet and use your JBK. So then we will just add some Winstons, just like, let's say, fake money. And then we will need to read these files I mentioned, so the file with compiled contract and with initial state. Then we just need to update the initial state with this wallet address we generated previously. And the last part, we have this methods in our SDK, deploy method. You just need to indicate wallet, the initial state, and the contract source. So yeah, I think that's it for deployment. So I will just run this script. As we are in TypeScript mode, I will use tsno, and then we just need to specify the path. Like this. Okay, so it's done, and we have the contract ID here. So as Kuba mentioned, we connected Sonar with testnet, so we can easily find it here. Right now it doesn't have any interactions, but we will change it. Most probably, you will be able to see the code as well as the state. Right now it's initial state. So let's go back to the app. And now we have it deployed. We can connect it to the front-end part, which is here as well. So the only thing which we will need to do is to replace this this contract ID. Like I said, when you're in the challenge mode, you will write some more also in the front-end part. But for the purposes of this presentation, I will just do it like this. And then I just need to create a secrets folder for the mainnet. Don't worry about it. It's just for the purposes of it to work. So I think it's like this. So now we will run the app. It's in view, as I mentioned. Okay, it's running on port 8080. So yeah, you can see the contract we created. As you remember, the initial state of it here has these two balances. Usually you don't put it here, but for the purposes of the test environment, I can do it. So you can see it here. And then we have two possibilities. We can either mint some tokens. Okay, so we have the interaction here. And we can easily find it. Maybe I will refresh it. You can already see it here. Or we can also find it like this. So you see all the little details about this interaction. I will not guide you through it, but you can read it later. And then we have the other possibility to write an interaction of transferring tokens. So yeah, let's do like 50. Okay, and we have another interaction, which I closed. Sorry for that. But yeah, I think, yeah, as well, we can see it here. So again, I think it's working correctly. So I think it's cool for the beginning. I mean, this tutorial, but I also advise you to try to write it in WASM if you are more experienced and you want to to practice some other implementations. We have this this repository with WASM templates. Yeah, here. So you have 3 options, either to write in assembly script, Go, or Rust. And again, the templates are for PST contracts. So if you are familiar with this contract and you already you wrote it, then you can easily transfer the knowledge of the PST here to the knowledge of WASM contracts. So I think it's quite easy to start it, even if you are not familiar with any of these languages. So yeah, as a bonus, let's say. So yeah, I think that's it from my part. I will stop sharing my screen.
Perfect. Thank you very much, both of you. Thank you for the overview, and then thank you also for the technical walkthrough. So if you guys also want to ask questions to Asya or Jakub, we're going to go into the Mingle session now. So feel free to join us there, and we'll see you guys down there. See ya.